So the next part that we're going to look at is we're going to look at polynomials. So limits at infinity of polynomials. So what happens, for example, if we look at the limit as x approaches infinity of x squared? So what happens here? Well, look at the graph. The graph of x squared looks like a parabola. As my x grows larger and larger, what are my y values doing? They're also growing larger and larger, so I can have this is equal to infinity. So you can absolutely have a limit at infinity equal to infinity. This just says as x grows without bound, so does my function. So here x squared. Another example, what about the limit as x approaches infinity of x to the fourth? Well, x to the fourth looks very similar to x squared, so that's also infinity. So you can definitely, absolutely, you can have infinite limits equal to limits at infinity. So just because this is x approaching infinity, this doesn't have to equal a number. It could also equal infinity. Now the theorem that we're going to use from this is that for a whole number n, the limit as x approaches infinity of x to the n is infinity. And the limit as x approaches negative infinity, well, this is going to depend on if n is even or odd. Oops, x to the n. It's going to be infinity if n is even, and it's going to be negative infinity if n is odd. So if we're just looking at a monomial, so just x to some power where n is a whole number, anytime I'm approaching infinity, regardless of what n is, it's infinity. If I'm approaching negative infinity, it's going to depend. Is n even or is n odd? If it's even, then it approaches infinity. If it's odd, it approaches negative infinity. So what should you think about in your head? This is just kind of a thought bubble here. Think about x cubed. The limit as x approaches infinity of x cubed, you can see my y values go off towards infinity. But what about the limit as I approach negative infinity? Well, as I get larger and larger in the negative direction, my y values go toward negative infinity. And that's because this is an odd power. Now we already did x squared, and that's what you want to think of the even one. So on the even one, so x squared, I would have kind of this extra part over here. So this is x squared, here's x cubed. That's what you want to kind of think in your head, is that regardless of the power, in the positive direction, I always go towards towards positive infinity. But in the negative infinity direction, depends on if the power is even or odd. If it's odd, I go towards negative infinity. If it's even, I go towards positive infinity. So that's our theorem about polynomials. Now, if we have a polynomial, that's monomials. If we have a polynomial, so let's say we're looking at the limit as x approaches infinity of x cubed minus 5x squared plus 1. Whenever you have a polynomial like this, the behavior towards the end is just going to behave like the leading term. So whatever my highest powered term is how it behaves. So what's the limit as x approaches infinity of x cubed? Well, this is just infinity. It's not anything weird, so this is just infinity. So whenever I have a polynomial, the behavior at infinity, again, this is only at infinity, behaves just like the leading term. So another example, let's look at the limit as x approaches negative infinity of x squared plus 2x minus 3. Here I have a limit at infinity of a polynomial, so it's just going to behave like that first term. That's the only term I have to look at. Is this an even power or odd power? It's even. Regardless of a positive or negative infinity there, this is going to go towards positive infinity. And then lastly, what about the limit as x approaches negative infinity of 5x to the fifth minus 3x squared plus 2? So I have a limit at infinity of a polynomial. So it's going to behave the same way as just my leading term. Now it doesn't matter that I have this constant here. I could bring out the constant. This is an odd power of x, so as x approaches negative infinity of an odd power, that goes towards negative infinity. The coefficient here doesn't matter. I mean, what does multiplying infinity by 5 do? It just goes towards negative infinity. So for polynomials, we only have to look at my leading term. That'll tell me if I go towards negative or positive infinity.